Hi there, welcome to this video. Thanks for clicking on and watching. Hopefully you've done so because you're sitting Maths Edexcel A-level this summer and you want to get an idea of what to expect on the day. The exam board have produced some mock papers, and looking at previous recent papers, I've put some questions together that my pupils have been having a go at, and the questions in this video are on pure stats and mechanics, and they're based on things that my pupils have been finding tricky recently. Now, nobody can predict what's going to be on the papers, and you should just use these videos to have a look through to see what to expect on the day. Do not use them to narrow your revision down. You should still be doing a broad range of past papers yourself and revising everything on the syllabus. Starting off by looking at some mechanics questions. So we've got a particle P moving with velocity, and we can see here that the velocity is dependent on time in both directions. The velocity is not going to be constant. We're not going to have constant acceleration, so this is not the sort of question where you're going to apply your Suvat equations. This is the type of question where we need to differentiate to find acceleration, and in part C, when we're finding the position, we need to integrate. So part A, we're just asked to find the speed, and part A, speed is equal to the magnitude of the velocity, because speed is just the scalar of the vector velocity. So finding the speed when t is equal to 4, first of all we need to find the velocity. So if t is 4, 2 times 4, we're going to have 8 in the I direction. 4 squared is 16 times 3, we're going to have minus 48 in the J direction. And then finding the magnitude, how do we do that? We're going to apply Pythagoras' theorem. So it's 8 squared plus 48 squared, and then take the square root. On our calculator, that comes out to be 48.6 and so on, but we usually give our answers to 3 significant figures, so that's 48.7, and that will be in meters per second. Now, part B, we are going to be differentiating. If we just explain why a little bit, if we've got the velocity time graph, and if we've got constant acceleration, then the gradient of that graph is equal to the acceleration. But because we've got variable speed, we're going to be differentiating to find the acceleration. So A is equal to dv by dt. So differentiating both components, we're going to get 2i and then minus 6tj. Now when t is equal to 4, we just sub that in, you're going to get 2i minus 24j, and that will be meters per second squared for acceleration. Now in part C, we are going to be integrating, and we just go back to our velocity time graph. When velocity when acceleration is constant and we've got this type of graph, then it's the area that's equal to the distance. But because we've got our variable velocity, now we're going to have to integrate to find that area. So r, which is the position vector, is going to be the integral of v dt. So now integrating both components, that's equal to 2t squared over 2, which will just be t squared in the I direction, and then integrating in the j, we're going to get 3t cubed over 3, which is just going to be t cubed in the j, and then we will also have our integration constant, which is also going to be a vector plus c. Now we're given some information that when t is equal to 1, the position is the minus 4i plus j, so we can feed that in to try and to find our c. So when t is equal to 1, r is equal to minus 4 1. I like to work in columns, and that's going to equal to, when t is 1, feeding it in here, you're going to get 1 and minus 1 plus rc. So we can just take that over. Minus 4 1, take away 1 minus 1 is equal to rc. So that's telling us that c is equal to minus 4 minus another 1, minus 5 in the I direction, and the minus 1 minus minus 1 is going to be plus 2 in the J direction. So R is equal to, now in the I, we've got our T squared and our minus 5 from C. So collecting the I components together, it'll be T squared minus 5 in the I direction. And in the J direction, we've got a plus 2 and a minus T cubed. So that will be 2 minus T cubed in the J direction. And when T equals 4, we can just sub that in. The position is going to be 4 squared is 16 minus 5, so that's 11 in the I direction. 4 cubed is 64. 2 take away 64 is minus 62 in the J direction, and that will be in meters, and that will be the position at T equals 4. Here's another mechanics question, and this one is from the other end of the course because we've got constant acceleration now. We're going to be asked to draw a speed time graph. We have got two trams there initially at rest in the depot and they're level with each other. At time t equals 0, A starts to move. It moves with a constant acceleration for the first 5 seconds and then goes at a constant speed. At t equals 20 is when B starts to move, going in the same direction. B has constant acceleration of 3 for 4 seconds and then B moves at a constant speed. And we're asked to sketch all this on a speed time graph. So let's put our axes in. Our speed time graph, we've got speed on the Y and time on the X. So A is going to start at t equals 0 and it's going to move with acceleration of 2 for the first 5 seconds. So if the acceleration has to be 2, that is the gradient's got to be 2. So gradient is rise over run. So how high is that going to reach so that when we divide by 5 we get 2? It's going to have to be 10. 10 divided by 5 will give us a gradient of 2. Now tram A then moves at constant speed. So that is tram A. Tram B sets off at t equals 20. Now tram B accelerates for 4 seconds. So he's going to go like this for 4 seconds. So that will be 24. Now the acceleration for tram B is going to be 3. So because we've got 4 along the bottom, what height will the tram B go to on the y-axis? It's going to be 12 because 12 divided by 4 is going to be 3, and tram B then moves at a constant speed. So this point here is just when tram B is travelling at 10, but because he's set off so much later, it's not going to be the point where he's going to overtake, but we can see because for the first 4 seconds tram B does accelerate and go higher than 10, there'll be some point when they're both travelling along when they've travelled the same distance and tram B would overtake tram A. Now we're going to find that by looking at the areas under both of those curves and seeing where they're going to be equal, and that's going to be the point where they overtake. The point here where the two lines cross is just the point where tram B has reached the same speed, but obviously it's further down the line because it's set off so much later. At the instant when the two trams are moving with the same speed, so that's going to be this place here where the speed is going to be 10 for both of them. Tram A is d meters in front of tram B, and we're being asked to find what that value of d is. So tram B is still on its accelerating part of the graph. It hasn't reached its final speed before it travels at a constant speed. It hasn't overtaken B because it's set off so much later. But what we need to do is find the time when that happens. Now for tram B, because it is still traveling and accelerating, we can use that V is equal to U plus AT and just put in that we want what is the time when that happens when the final speed is 10. So that will give us the time that that happens. Now U for both of the trams is 0, and A for tram B is 3, so that's going to be 3t. So t is equal to 10 over 3. So tram B has been travelling 3 1/3 seconds. So overall, from when A started the whole journey, this will be 23 1/3 seconds. So now what we need to do is find the distance that B has travelled, which will just be that small triangle there up to the 23 1/3, and find A's triangle here plus A's rectangle, and then take them away from each other. So distance for tram B will just be a triangle, which will be half times 10 over 3, which is just going to be that base there, times 10, which will be 100 over 6, which is 50 over 3, and that will be meters. Now we need to do tram A. Tram A's initial triangle will be half times 5 times 10 plus the 23 1/3 minus 5, because we want just that rectangle, and that's going to be times by 10. Now if you do that on your calculator, that comes out to be 625 over 3. And then to find D, which is how far tram A is in front of tram B, we need to take them away from each other. 625 over 3 minus the 50 over 3 gives us 575 over 3, and that's going to be 191 2/3 meters. For part C, we're being asked to find the distance of the trams from the depot, the instance when B overtakes tram A. Well, B is going to overtake tram A when they're at the same distance away from the depot. So that means there'll be some point T further on in both journeys where the area underneath both of those curves is equal, and that will mean that they are at the same distance away from the depot, and therefore B will be overtaking. So we need to look at the areas underneath. So for tram A, its area is going to be the initial acceleration part, which is a triangle, so it's going to be half times 5 times 10 plus the rectangle, which will be made up of a base of t minus 5 times 10. Now if we do the same for tram B, its first triangle is going to be half times 4 times 12 plus then its rectangle is going to be here a t minus 24 times the height of that rectangle, which is 12. Now we need to make those equal, so if we do this initial bit 5 times 10 and then half that is going to be 25 plus 10t minus 50 has to equal 4 times 12, 48, and half of that is 24 plus 12t minus 288, 12 times 24. So if we collect all the t's on one side, we can have 2t on this side is going to equal 239. So the t where all this happens is going to be 119.5 seconds. So that will be there. That's the point where B will overtake, and then we just need to put that time into either of these, or you could put it into both to check. But when you have t is equal to 119.5, the distance where B overtakes will be 1,170 meters from the depot. Next, we've got some pure questions, and this is a differential equation question. More recently on the mock papers, I've seen them asking you to form your own differential equation. But in this question, we have the differential equation. We're asked to explain why that we have this equation. So the situation is that we've got liquid pouring into the container at a rate of 20, but it's leaking out at a rate that's proportional to the volume in the container. So we can write that dV by dt is the rate of increase in volume with respect to time. So volume in at rate of 20, but the volume out is proportional to V, and V is volume in the container. So minus kV is negative as volume is leaking, and K is the constant of proportionality. So overall, we've got our dV by dt is 20 going in and then minus kV going out. In part B, we're told that the container is initially empty, so T is equal to 0 when V is 0. We've got to solve our differential equation and end up with VV in the subject. So our differential equation was dV by dt, which was 20 minus kV. How do we solve differential equations? We need to separate the variables and integrate. Now, because this is a minus, we're going to have to take all of that down. So it's going to be 1 over 20 minus kV dV is equal to the integral, nothing else left on the right, so that will just be dt. Now we're going to integrate, so this will be the ln of 20 minus kV, but because of the reverse chain rule, we'll have to then times by minus 1 over k on the front is equal to t plus c. Putting in those initial conditions, minus 1 over k, the ln of 20 is equal to c. So writing it all out, we'll have minus 1 over k, the ln of 20 minus kV is equal to t minus 1 over k, the ln of 20. Now, taking all the ln's to one side, we'll have 1 over k, the ln of 20 minus 1 over k. 20 minus kV. Take the 1 over k out, and then using our log laws, we'll have the ln of 20 over 20 minus kV, and that's equal to t. Still got our t on the other side. If we times by k, we'll have the ln of 20 over 20 minus kV is equal to kt. Now if we raise each side to the e, we'll have 20 over 20 minus kV is equal to e to the kt. Now a little trick here, we're trying to get to the minus, so we want a minus there. That will send that side upside down, so we can just turn the other side upside down and get 20 minus kV over 20 is equal to e to the minus kt times by 20. 20 minus kV is going to be equal to 20 e to the minus kt. Take the kV over, 20 minus 20 e to the minus kt is equal to kV, and then 20 minus 20 e to the minus kt all over k is equal to V. So V is going to equal 20 over k minus 20 over k e to the minus kt. So it says in terms of k. Now having a look at part C, and we're given some more information, and that's going to allow us to find k. Now initially we had our differential equation dV by dt was 20 minus kV. Now that would be okay if we had V, but we're not. We've got t and we've not got V. We're told that dV by dt is 10, but we can't use this equation because it's not got any t's in it. So what we're going to have to do is use our equation from b, which was 20 over k minus 20 over k e to the minus k t, and then differentiate this with respect to t. So dv by dt. The first term hasn't got any t, that's just going to go out. Differentiating with respect to e is going to stay the same, but because of this minus k, that will come down. The minuses will cancel and the k will cancel. So dv by dt is 20 e to the minus kt. That is 10 when t is 5, so sub that in. Now take the 20 down, so 10 divided by 20 is a half, is equal to e to the minus 5k. Now e to the minus, that just means that we've got a half is equal to 1 over e to the 5k, because minus just means it's underneath, and then that denominator has to equal that denominator, so we can say that 2 is equal to e to the 5k. And then taking ln's, ln of 2 is equal to 5k, so 1/5 the ln of 2 is equal to k. Now you could, when you go back to this stage here, that minus, you just know that that means it's underneath, so you could just turn the 2 upside down and say that 2 is equal to e to the 5k. Either way, we've got our k, so now let's put it in for v. V is equal to our 20 over 1/5 the ln of 2 minus 20 over 1/5 the ln of 2 e to the minus 1/5 the ln of 2 t. Now I don't like having fractions in fractions, so that 1/5 on the bottom would come on the top and make the top 100. So v is equal to 100 over the ln of 2 minus, same again on the other one, 100 over the ln of 2. Now we're going to put this e to the minus 1/5, we're going to use our log laws and say that's e to the ln of 2 to the minus 1/5, and then it's all of that times by t. So what we can do is put the t on the outside, because that would cause those two to be multiplied, and then we can cancel our ln's. So v is going to be 100 over the ln of 2 minus 100 over the ln of 2, and then it's going to be 2 to the minus 1/5 all to the t. So now we're trying to find what the volume is when t is 10. So if we sub in that t is 10, we're going to times those two together. So this term is going to be 2 to the minus 10 over 5, which is 2 to the minus 2, which is going to be a quarter. So v is equal to 100 over the ln of 2 minus 100 over the ln of 2 times a quarter. So that quarter and that 100 can be 25. We've got common denominators, so 100 minus 25 is going to be 75 over the ln of 2. This next question is a parametric equation question. We've got 2 points on a curve and we have a tangent to the curve at the point A. So we can see the coordinates of A are 0 in the x and a half A. So in order to find the equation of the tangent, we need a point which we have, but we also need a gradient, m. Now the gradient of the tangent is going to be the same as the gradient of the curve. So what we need to do, because x is equal to 0, at a, x is equal to 0. So if we put 0 into our x equation and find the t that happens, and then we need to differentiate parametrically and sub that same t in to find what the m is, and then use our equation of a straight line. So at a, x is equal to 0, so 0 is equal to a cos of 3t. Now two things timesing together to equal to 0. Well, a can't be 0 because we can see a is a point on the x-axis there. So cos of 3t will have to equal to 0. And then thinking about our cos graph, where does the cos graph equal 0? There at pi by 2. So 3t, the angle, will have to be pi by 2. So t will have to be pi by 6. So if you want to think of in terms of degrees, that's 30 degrees. So now differentiating parametrically, we need dy by dx, which is going to be dy by dt times dt by dx. So informally, they can operate like fractions and cross multiply, so the dt's would cancel. So dy by dt, I can see I can differentiate that easily, but I'm going to have to turn upside down dx by dt. So let's just do that separately. Dx by dt is going to be minus 3a sine 3t. Okay, so dy by dt is going to be a cos t times, and we need to turn this upside down, so that will go over minus 3a sine 3t. The a's will cancel, and now we'll need to sub in what is the gradient when t is equal to our pi by 6. So cos of pi by 6, well, if you think of your special triangles, or you can just use your calculator, pi by 6 is 30, and sine 30 is a half, opposite over hypotenuse. By Pythagoras, that is root 3. So cos 30 is root 3 over 2, and that's divided by minus 3 sine of 3 pi by 6, which is equal to sine of pi by 2. So on our sine graph, the sine of 90 is 1, so that's minus 3 times 1. So this is root 3 over 2 divided by minus 3, which is going to be minus root 3 over 6. Now we need to use our y minus y1 is equal to m into x minus x1. The gradient of the tangent will be the same as the curve. The y coordinate is y minus half a is equal to minus root 3 over 6, and it will be x minus 0. So all we need to do is now go y is equal to minus 3 root 6x plus a half a times throughout by 6. 6y is equal to minus 3 root x plus 3a. So let's have a look at part B. We're being asked to find the area of this finite region between the curve, the tangent, and the x-axis. Now, in order to do that, we're going to find the area of the triangle. We're going to do half base times height, and then we're going to take away the area under the curve, and we've got the curve given parametrically, so we're going to do parametric integration and take that away. So in order to find the area of the triangle, we're going to need to find this place here, which is where the tangent meets the x-axis. So what was the equation of our tangent? It was y is equal to minus root 3 over 6x plus a half a. Now what's happening when a line meets the x-axis? Y is equal to 0. So if we equate that to 0 and solve for x, taking this minus term to the other side, we'll have half a is equal to root 3 over 6x. Cross multiply 6 over 2 root 3a is equal to x. So that will be 3 over root 3a is equal to x. Rationalize the denominator, so times by root 3 over root 3, and then the 2 root 3's here will give us 3, which will cancel with that top. So then we'll just have here, this point will be root 3a. So the area of the triangle is going to be half times root 3a times the height of the triangle, which is half a. So altogether that's going to be root 3 over 4 a squared. Now looking at the curve, we're going to be integrating between 0 and a. but that would be with respect to x if we had y in terms of x, but we haven't. We've got y in terms of our parameter t, so we need to change the integral and have these limits in terms of t, have the y in terms of t, times it by dx by dt, and then dt. And then remember, informally, these can behave like fractions, so we will just be doing that integral, which will give us the area under the curve. So we need to find our limits first. So we already know that when x is equal to 0, t was equal to pi by 6. Now, when x is equal to a, we're going to let a equal a cos 3t, because that's the x equation. We're going to cancel by a, so dividing both sides by a, we'll have 1 is equal to cos 3t. Having a look at our cos graph, where does the cos graph equal 1? It's there at 0, so it's going to be 3t will equal 0, so t will equal 0. So it's really important that that upper limit is now 0 and the lower limit is now pi by 6. So you must put them in the right order. So we're going now from pi by 6 to 0, and we're going to be integrating y, a sine t, times the differential of the x. So differentiating cos is going to be minus a sine 3t, and then we'll also have a 3 there, and then that will be with respect to t. So what I'm going to do now is take these constants out of the way, so it will be minus 3a squared sine t sine 3t between pi by 6 and 0. Now, because these limits are upside down and we can see that we want to have a positive area, what we can do is that minus can just mean that we can switch those limits round. This is going to be the same as 3a squared going from 0 to pi by 6 of sine t sine 3t dt. Now having a go at the integration, and I've just written here the area of the triangle because we're going to take our answer away once we've integrated from the area of the triangle. So we can see here that we've got two terms being multiplied, so we could do by parts, but you're not going to get rid of anything by doing by parts once. You're going to have to do it again twice, and then manipulate it so you've got some multiple of the integral, and try and do it that way. Or you could notice that this is a sine. Where do we see that? We see it in the addition formulae for cos. So if we have a look at cos 2t, that could actually be cos 3t minus t. Now, how does that expand? It's going to be cos 3t cos t plus sine 3t sine t. And this is what we're getting at because we've actually got that there. So how are we going to get rid of this bit? We can have a look at now cos 4t, which is going to be cos of 3t plus t, which would be cos 3t cos t minus sine 3t sine t. So can you see if I did cos 2t minus cos 4t, then it will be all of this minus all of this, and these terms of the cos will cancel. We'll be having minus minus, so we'll actually have 2 sine 3t sine t. So what we can do with our integral is go 3a squared over 2 times the integral between 0 and pi by 6 of 2 sine t sine 3t, and then all of this is going to be 3a squared over 2, the integral from 0 to pi by 6 of now this, which is easier to integrate, cos 2t minus cos 4t with respect to t. So now it's easy to integrate 3a squared over 2, and we're going to times that all by the integral. Integrating cos is going to be a half sine 2t minus a quarter sine 4t between 0 and pi by 6. So we've got our 3a squared over 2, putting our limits in. Pi by 6 doubled is going to be 2 pi by 6, which is pi by 3, which is 60 degrees. Sine of 60 is half root 3 over 2 minus, and then when we do 4 times pi by 6, that's going to be 2 pi by 6, which is 120, which is also root 3 over 2, so that's a quarter root 3 over 2. And then our other limit, when we put t in as 0, sine of 0 is just going to be 0 minus 0. So we don't need to worry about that bit. So here we've got 3a squared over 2 root 3 over 4 minus root 3 over 8. So altogether that is going to be 3a squared over 8 times root 3 minus 3a squared root 3 over 16. And if I just put that all over 16, I'm going to have 6a squared root 3 minus 3a squared root 3 all over 16, which is going to be 3a squared root 3 over 16. Now to find my total area, I need to do the area of the triangle, which is root 3 over 4a squared, take away 3a squared root 3 over 16. If I times this one by 4, top and bottom, I'm going to have 4 root 3 over 16 a squared minus 3a squared root 3 over 16. So altogether, 4 minus 3 of something is just going to be root 3 a squared all over 16. I'm going to finish off with just one stats question, and this is on correlation. We've got a meteorologist believing that there's a relationship between daily wind speed and daily mean temperature. We've got 9 consecutive days taken from a town in the UK in July with these results. We also have the product moment correlation coefficient for these 9 days is 0.609. For part A, we're being asked to explain why linear regression based on these data is unreliable for a mean temperature of 24. So we can look at the temperature range for these 9 days, and we can see it goes from 13.2 to 19.3, and 24 is outside this range. So if I had this data on a scatter graph and drew my least squares regression line, you would have to extrapolate that line to take any readings about 24. And when we extrapolate, extrapolating is unreliable because we can only draw conclusions based on the range we've got. We don't know what's going to happen to the wind speed when the temperature gets outside our range. For part B, we're being asked to state what is measured by the product moment correlation coefficient, and that is the linear association between the two variables. In part C, we're stating our hypothesis clearly, testing at the 5% level whether or not the product moment correlation coefficient for the population is greater than 0. Now, when you're doing a hypothesis test for correlation, your starting point, your null hypothesis, is always that rho, which is the population product moment correlation coefficient is equal to 0. Your default starting position is that there is no correlation. You remember the scale goes from -1 to 1, 0 being no correlation and 1 being perfect positive correlation. So your alternative hypothesis from the question here is that rho is greater than 0. Now we look at a sample size of 9 and at the 5% level read off this value here, which is our critical value. So if we put that on there, 0.5822, that is the cutoff point. Anything above that, closer to the 1, is going to tell us that we're going to reject our null hypothesis in favor for the alternative. And 0.609 is bigger than our critical value. So that is the critical value. So we are going to reject H0. There's evidence that the product moment correlation coefficient is greater than 0. Now, part D, we're told that using the same 9 days, so it's going to be in July from the large data set, we've got a mean temperature of 27.2 and a mean wind speed of 3.5. Using our knowledge from the large data set suggests giving a reason the location that gives rise to these statistics. So we can see the temperature range for this town in July goes, as we said before, between 13.2 and 19.3, and this temperature is much higher, so it's unlikely to be a place in the UK, and the wind speed is much lower. So the 27.2 is higher than the UK. So that's going to suggest it's somewhere abroad, and the 3.5 is low. So this suggests not near the sea or the coast. So what could be a place in the large data set? That is going to be Beijing. Thank you so much for watching. I hope you've given it a like at some point and you found the content of the video useful and helpful and your revision is going well. Good luck if you are taking your A-levels this summer, and I will see you on the next one.